Okay. So 5.4.4, right? Of course, we go to games. We can choose anything here. For this demo, I will be using third person. Yeah. So you should have it here. On the right side, before you create the project, you have to choose C++. The moment you use Blueprint, it's locked in as Blueprint. You cannot change it to C++ anymore. So make sure it is in C++. You have the starter content. Let's call this demo project. Now, this is going to take uh, a few, mm, maybe a minute or two when it creates the C++, because remember what I told you, when you first launch it, it takes a while, especially here, because it's creating all the scripts, or maybe not creating, but it's copying all the scripts of Unreal Engine, all like the scripts of the components, the scripts of the actors, of you objects. It's doing that there, generating code, compiling C++ source files. It's gonna take a while, so you're gonna have to bear with me also for this. Maybe I should have started before, but uh, I just want you guys to see how long it takes. There we go. That's actually isn't the end of it. Okay. One thing to note here when you first start it, um, or when you actually use Visual Studios, is this button on the lower left. Well, so what is this? It just I don't know. It just tells you what is happening with Visual Studio right now. This you want to know about this because when you start coding and uh, you're questioning why isn't the autocomplete happening, it's most probably because of this. It's telling you maybe it's trying to parse something first or whatnot. So if you think if you see like autocomplete is not working, check this out first. Maybe it's doing something. If it's not doing something, then most probably you did not include a certain script. No, so it's just I don't know. It is just telling you what is happening currently in Visual Studio. So while this is still parsing, it's gonna take a while. You will notice. Oh wait, uh, did anyone here use Visual Studio? Oh, Visual Studio, Unreal Engine 4 back in GAMPRO 1? Did everyone use? Oh no, sorry, Unreal Engine 5. Did everyone use Unreal Engine 5 back in GAMPRG 1? 4. So there are people only who only used 4 lang. Okay. Okay. That's all right. So this is the new um UI for Unreal Engine 5. There are some changes. Uh this is darker. This is the darker gray. I remember the Unreal Engine 4 ata is a bit lighter. Anyway, you still have the play buttons. Yeah, you still have some stuff here. I guess. Oh, uh, like when adding also the objects, I guess it's here. If you want like the basic actors or if you want shapes, yeah, this is the one. If you want volumes, oh, I think there's also a window for that. Place actors there. If you want this here, yes, you'll go through windows. If you want lang, you can choose not to. What else is new here? Here, content drawer. Right now, it's a collapsible one, or you can choose to dock it. So when you dock it, it's now part of the window. You have the outliner. Anything else? I think that's it. At least for the UI. Okay. Now there's a button here that's very the mo. It's very important. It's very important when using C++. Why? Unlike in Unity when you create a change in your script, it automatically compiles it for you. It's like there's a loading. There's a it runs it compiles it. There's a loading bar, and then okay na it works. In here, you have to manually um compile your code, and it's so important, but it's such a small button. Down here on the lower right is the button to compile your code. So after you make your changes, you have to compile it, or else the changes that you did will not reflect in the editor. So it's this button. The button is this uh bricks. If that's all I can think of. Pixels just being formed. So it's down here right here. Beside the all saved and the between the all saved and the derived data. Another thing that's important is this enable live coding. I would choose to disable and live coding. I think what it does is I think something like in Unity, but uh for me is kind of finicky. It's new for Unreal Engine 5. Unreal Engine 4 didn't have this, but I would choose not to enable it. I'll have it disabled. Okay, so that's an important button. Then there should be a new folder here. Before you'd have just a content folder and then all the other folders. Now you have the content folder and the C++ classes. And just from the name of it, it holds the C++ classes. It holds both the header file and the CPP file, but what will appear here is just the header file. Oh, well, technically, if you try to open it, it will show both the header file and the CPP file. Okay. Uh, follow. Is everyone following? So just important button. Okay. Okay. So if you want to create a new C++ class, there are two ways to do it. To do it. One is from the content browser, under the C++ class, you can right click in the content browser. When you right click, it will show new C++ class. When you create it, when you press it, this will appear. The other way is through tools, new C++ class. So there's the two ways in opening this thing. You can just right click here or tools. For now, we will create a actor. Let's call it demo actor. I'm thinking if I want C, could have C on it. Nah, actor, demo actor. You can choose to make it public or private, but most of the time I don't really click on this. Unless you really or you really want to make things public or private. Uh, but for now, I won't choose anything here. Just leave it blank. You said just change just the name. This one, yeah, it stays as is naman. Then path, just leave it. Then we create the class. So when you create the class, what it will do is it will compile the code. So each time you create a class, it will compile a code. The thing is, if you, let's say, created a class, there's a problem with it, and then you created another class, it will not, the other class will not show until you finish or fix all the bugs from any of your other scripts. It'll appear naman eh. Lalabas dito compiling error. Then you see that the new class isn't here yet because there's something wrong with your code. Okay. So Visual Studio right here. There's one thing that I want you guys to be mindful of is this Solution Explorer. So in most cases, let's say in Visual Studio, in Unity, we don't really notice this. Minsan we'll just open a script within Unity and then you work on that. Here though, for me, the Solution Explorer is quite important. It holds, you see here, all the classes, all the scripts of Unreal Engine. So this is what I'm telling you that you can access the base code of it. You can literally search the actor. Well, maraming lalabas na actor because there are lots of things that called actor. But I think that age. Will this help? Will that will this help? Not really. So anyway, yeah, you can search anything here. And we're gonna be using that capability later. So if you want to go to your scripts, it should be under games, and then here's our scripts. Uh, you can still you can still use this one. You can still open here, but just so you know, it's under games. So C++ here. Uh, huh. So it's just like if you remember Basprog. Oh, it's sorry. Any questions so far? Following? Everyone still following? Well, so if you remember Basprog, you create a public or private um, access. You do the public colon, and then you can put here whatever you want. So it doesn't mean just for one lang. You can do multiple, like enter to health something, or float speed, right? So there's that. Uh so now we'll create the variables. These variables, I'll show you different ways about the different specifiers for it. So for example, let's say our int32. Int32, let's say these are health. If I want to make it appear in Unreal Engine, oh here, you know what? Let's go with that. Int32 health for now. If I try to compile it, there, compile complete. Then in order to create an actor for it, let's put a new folder here, demo project. If I want to create the blueprint for it, it's under all classes. If I search for demo actor, it should appear here. It is under actor because we said we want to create an actor class. So here, demo actor. Let's call it PP demo actor. So you see here that I typed here health. It's not gonna appear here at all. It's not gonna appear in the PP demo actor. There's nothing here because we did not specify um, what we want to do with it or how to show in Unreal Engine. Hence, that's why you need to use the U property. So not only do we need to use the U property, we need to use specific specifiers that you want to use. So again, U property is this thing is a macro. It will not appear automatically. Oh well, maybe it does. U property. So if you recall the specifiers, if not, you can always research it. Uh, if we do Unreal Engine, U property specifiers, it'll appear here. All the specifiers that you want to use. But if not, I mean, if you remember it naman, or if you have the PowerPoint, then you can use that. So it's mostly just the ones up here, all here. But we'll go through each. So one is visible anywhere. What visible anywhere means is it will just be again visible in the editor, but you cannot edit it. It will just be a blank, uh, a a like a disabled text box kind of. It kind of looks like that. That will be visible anywhere. Then if you want to put another specifier, you just separate it by a comma. Another one will be blueprint read write. So if I say blueprint read write, it'll be I can call it, I can get a getter for it and a setter for it in the blueprint. So if I want for let's say the max health, I would have a U property. Maybe I want it edit anywhere. But this one, let's just use blueprint read only. Blueprint callable. No. Oops. There. You have to make sure that the spelling is right. If the spelling is not right, it's not going to do anything about it. So no background task is running, so everything is okay. So if I compile this, oops, if I compile it, there. If I search here health, which I already typed in here, this is where we have it. This is the visible anywhere. The health here is the visible anywhere. This here is the edit anywhere. So in here, I cannot edit this, but this one, I can change the numbers. So there's that. Then remember I used the blueprint read, right? And blueprint read only. If you go to the blueprint and I typed here health, you'll see these. If you remember the health one, I had blueprint read write. So we'll have here the read, which is the get health, and the write, set health. However, in the max health, I only said blueprint read only, and hence we only have the get. We don't have the set because we only said read only. And it's the same thing. How it's like creating variables here. Uh, it'll appear here. It won't be here though. Whatever is in here is blueprint. So you won't see the actual variables that they created here. It'll appear here on the very top of the components, the actual actor. Okay, questions on creating variables. No questions. Okay, dali pa naman eh. So next will be functions. Now, in creating functions, it also has a different specifier for it. And we have three three specifiers that we usually use. Oh, right. If you want to categorize it, category equals to you can put spaces here. For this one, uh, compile. Oops, that is nothing. Sometimes Unreal does that. Um, there's a compiling error, but there's no error at all. Sometimes you just give it some few seconds and then it'll work now. Anyway, health. It now has its own category here, health. Right? So anyway, back to creating um the functions. So again, it's kinda needed kung anong access modifier yung gagamitin niyo, public or protected or private. And you'll see later. In this case, let's say protected. In the protected, let's say I want void deal damage. Oh no, take damage. Take damage in amount. Or let's say void dead. Uh and let's also do a float get health percentage. Okay. So same thing like what I showed you a while ago. If I created um all these functions, I try to compile it, I'm not gonna be able to find it here. That take damage or health percentage. No, none, because again, we need to use a proper specifier for it. So let's say take damage. For take damage, I want a u function blueprint callable. So if I say blueprint callable, I can call the function. That's why callable. Then let's say for dead, I want u function. For here, I want blueprint implementable event. Remember, blueprint implementable event is I implement the code for it in blueprint, but the I am able to, let's say, call the function here in C++. So that's blueprint implementable event. And finally, new function blueprint pure. Blueprint pure is it's like the blueprint callable, however, it doesn't have that line anymore. You don't have to connect it to a line. What we want for pure functions is to just give out a uh, let's say you wanted to calculate something, and then that's the value that you want to show out. That's literally it. Okay. So for this, let's say take damage, I will create the definition. And then this one, I'm gonna create the definition, but I'm gonna tell you now right now that it is going to cause a problem. And then here I'll create the definition there. So if I try to compile it, there's going to be an error. There, compile failed. So let's try to read this error. It's going to be lots of words, but it'll kind of tell you here. Take damage function does not operate anyways. Oops. I think take damage is a actual yeah, sorry, my bad. Take damage is an actual uh function. So let's change the name. Take damage. Take take health damage. Okay, so never mind. Let me compile it again. It should still shoot another error. Okay, okay, this one. You'll see here there's no underline here, but you have to read through. You have to read through the compile, the log error. So you can see the problem here is already defined in demoactor.gen.cpp.object because one or more multiply defined symbols found. This is because we said that it is a blueprint implementable event. So the actual um, function will be done in blueprint. But since we created a definition for it here, that means there are now two definitions of dead, and Unreal Engine will not take it, or at least in C++ also, it will not take it. So in this case, all blueprint implementable events should not have any definition. All right, to automatically create a definition, if you hover, there should be a screwdriver. Then there's the create definition, copy signature. It's the create definition. That will automatically create the definition here. Okay. So anyway, yeah, there should be no definition for the functions that have blueprint implementable event. So if I compile again, it should now be all good. Hmm. Uh, yeah. So if we go to our actor again, it will not appear here. It will also not appear here. But if you right click for the actions of this blueprint and we type the, let's say, the take health damage, take health damage. So this is the callable function. And you notice here there's a amount here. Why? Because I used it in the parameter. So anything in the parameter, it'll appear down here. So if you have multiple parameters, it'll have the multiple lines for it. So let's take health damage. Then you see here, if I do dead, we have the add event only. We don't have the callable because I did not put blueprint callable in it. So it only has the add event. And if I click on it, it's just this. So it looks like the custom event, right? It's like creating a custom event, but this is it. So I will implement all the stuff in here. Then uh, if I call it in the C++, if I call dead, it'll run whatever's in here. Okay. And then finally, the blueprint pure get health percentage. This is blueprint pure. It doesn't have the lines here, but it will output a value. So Unreal Engine actually has this already. I mean the normal thing though. If you create a function, you see here pure. If I click on this, make it pure, new function. Yeah, it's the same thing. However, again, you need the output for this. So let's say float. Okay, so it's just pure. It doesn't have that line. So what should be in here though is just calculation and no actual uh you're not actually doing anything here. All right? Questions, clarification? Everyone's still following? Okay. So how do we put the components? Right now we haven't added any components yet. All we have is the um, int string, int float. Wala pa tayong actual component. So let us go code that. Remember here in components we add when you create an actor, if you add a component, it's here. If I want a static mesh, if I want a where's my colliders? Box collision or sphere collision, we add it here. And then remember that uh, we can also change the hierarchy. We can maybe set this as the root. We can do this as it's attached, the cube is attached to the plane. Remember, we could do that. In Unreal, in C++, it's quite a lot of things to do. It's not just one button. It's not like this. It's just press here. Okay na. It's actually a few lines of code. So, uh, I can put it under protected. Let's go put it under protected. So to create the components, one thing you have to know is what is the name of the component. Remember that I discussed where we have the prefixes U, A, F, T, right? The prefixes in here we have the U because it's gonna come from the U object. Then now we have to know the name. So the for the scene component of its U scene component, then it's automatic. Automatic na siya because it should be under actor. So U scene component or U static mesh component. So we have that. So this is easy pa. So let's say using component. Using component. I want this to be the root. So when you create a component, you have to make sure you have view property. And as much as possible, give it a visible anywhere. So it will appear in the editor. So that's my root. No, don't forget asterisk. What do you mean if it's an asterisk? What is this called? Kapag may asterisk yung data type, what is it called? Nako, nako, nag-buzzword ba kayo? Pointer, correct. And what is a pointer? What is a pointer? Anyone? Nako. Anyone? No? Forgot what a pointer is? Oh, did everyone use ChatGPT for BassPro? Okay, so pointer, again, it literally points to an address. So when you create a instance, when you create an instance, remember it will use a certain memory address in your RAM. The pointer will point if you set it right. If you set it, the pointer will point to that memory address, and we can do um we can do stuff with the pointer, and then it will also change whatever is in the address. Okay. Anyway, we have the using component, use static mesh component. I will call this static mesh. I can also call it mesh. Again, new property, visible anywhere. Okay, if I compile this, what's gonna happen? After compiling, what do you think will happen? You already heard it compile complete. So it won't crash or it won't show a problem. But what do you think is gonna happen after typing those? Will there be an actual scene component? Will there be a static mesh component on the actor? Anyone? Take a guess. It's okay to get it wrong. A static mesh? You think a static mesh will appear in the actor itself. Static mesh is the one where you could put a mesh in it, like the sphere or the plane. That's static mesh. The components can be seen in the actor. Okay, so if you open the VP demo actor, there's nothing here. You could search it if you want. Uh, what do you call it? Static mesh. It's not here. Why? Remember, a pointer points into a instance. Did you create any instance after typing that? Did you use any new something after typing this? Wala, 'di ba? So wala pa tayong instance. It's not pointing to anything. Right now, it's literally just a pointer pointing to nothing. Kahit na it's visible anywhere, it doesn't have anything. We have to code it. So under the constructor, remember constructor. Under the constructor, let's type in root. Root is equal to, this is where you create the component. Create default sub object. Oops. Sub object. This is in creating the component. Then less than greater than, this will be the type, the data type. So scene component. Then finally the parenthesis, all you want is just the name. The name will be root component. Okay. So that's right now, it is pointing into a scene, an actual component that we created. But in order to make it a root component, we need to type set root component. And then we put in here whatever um, component we want as the root. So now set root component, root. Then let's do also the static mesh. So static mesh, that's the name that I put here, static mesh. Static mesh is equal to create default sub object. Again, the data type. So static mesh component. Static mesh. You can name it anything you want. You can say static mesh. Then if you want to attach it to something, you would have to go static mesh arrow, because pointer is how you access its functions. Arrow set up attachment. So we want it to attach to something, the parent. For the parent, I would say it's the root. If you do not do this, if you also do not do this, it will create these components, but it doesn't know what to do with it. It will literally appear in 0, 0 of your world or level. So you have to make sure it is attached to something. Right now, we set it as the root component. And here we attach it to the root. If we do not have this, the game will literally create this component and it'll just be at 0, 0 because it doesn't know what to do. Just so you know. So if you see that the thing is always spawning at 0, 0, you know it has something to do with attachment. You did not attach it properly. Okay, so compile. And then you see here, nothing happened. It's kind of normal because we compiled it before before putting the components here. So in order for it to appear, what I usually do is what they call, it's like kind of refreshing the class. I would change the parent class here. In class settings, you have the parent class, meaning this is where it's coming from. What I would do is I'll just change it to actor, and then I'll bring it back as to the demo actor. I'm not controlling Z, I'm actually typing it, demo actor. And finally, this will appear. Okay. So there's another way. It's also here. If you do asset actions reload, it could work. It could also not work. So most cases, I just do class settings and then change the parent class to actor and then reparent it again. Just so it's like kind of refreshing the actor. Questions? Can the components can be seen in, oh, okay, we're done. Uh yeah, we're done with that. The component can be seen in the actor. Yes, it's here. Then if you put a static mesh, a mesh for it, capsule. So there's that. And you'll see here it is attached to the root component. Okay, questions, questions, clarification? None? Uh Again, you remember I just changed the name static mesh. So there's that. Uh okay, there's no questions. Let's try to create our character and controller. Hmm, do I want to? Yeah, sure. Okay, so let's create our character. Uh, New class character. I will call it demo character. Then you see here again, it'll compile your code first. There, compiling C++ code, compile complete. And it should now appear here. So demo character, H. So you see here, it's still doing things. That's why everything's just white. If everything is, if this is all done, the IntelliSense, don't mind also the red lines. So that's the weird thing again about C++. Sometimes mag-error sila and all of a sudden it's all gone. So it's mostly just a background task happening. Okay, for demo character, remember that we would want our spring arm and a camera, right? So under protected, I want the spring arm and the camera. What is the spring arm called? Can anyone remember? What is the spring arm called? The whole name of it. Can anyone recall? Spring arm. Okay, I see people typing. What is the component called? Spring arm. It's called a spring arm component. Whoa! What do you call the camera? How about the camera? What do you think is the camera called? The whole name of it. Camera component? Oh, who would have known? So if you were, if let's go here again. Uh, let's go here. In here, it's called a spring arm component. Spring arm. Well, actually doesn't show here, no. Spring arm. And then a camera. But here we have a actually it's called a camera and spring arm component. All everything else. Static mesh component. Um, for the colliders, it's box component, sphere component, right? The thing is, if you try to type here, use spring arm component, you see here it's not being auto completed. That means either it actually does not exist or it's not included in here, right? But remember, the good practice here is we do not include everything in the header file. Sometimes we want it only to appear in the CPP. So if you want to include a another from another class so that circular dependency does not happen, we just have to forward declare it, right? But the question is like, how would I know the name or the actual name of the component? This is where the solution explorer is helpful because if I type in spring arm component here, it will appear here. Or let's say camera. If I just type camera, there's gonna be lots of camera, but there's gonna be a folder here that is important. It's under source. Uh, was it runtime? I think it was no, not runtime. Source. I know engine, and then here you see that it's under all of this camera component. It is under camera there. It's under camera or our spring arm component. You have to remember where it's coming from. It is under the game framework. So you have to remember that later on. So if I want to say, let's say the spring arm component, what is it called here? U spring arm component. So I have to remember that. So U spring arm component, it's here. I will forward declare it. So there are two ways to forward declare. It's here or up here. Uh, you can do this also. I'm forward declaring it. There is a class called U spring arm component. You just have to trust me. So if I type here U spring arm component, it will automatic. And then spring arm. I'm trying to recall if this is gonna break something. No, it's not. And then remember, as much as possible, put a visible anywhere. Our camera component, it's called a U camera component. Again, it won't autocomplete. We will forward declare it. U camera component camera. Then U property visible anywhere. Hey, if I compile it, what's gonna happen? Will it create the spring arm and the camera? Yes? No? After I typed um, spring arm and camera here, will we now see the spring arm camera in Unreal Engine after I compile it? Correct. So it won't appear. Again, it's a pointer. We still have to create it. We still have to give it something to point to. So let's do that. Here. Uh-huh. Again, constructor, always on the constructor. Spring arm is equal to create default sub object. You spring arm component, spring arm. Now I'm gonna show you something. If I do spring arm arrow, you'll notice nothing is appearing. Unlike a while ago, uh, here in demo actor, if I do root arrow, it's gonna something's gonna appear. All of this, the IntelliSense will tell you, okay, these are all the functions you have. In here though, I don't have anything because right now we only forward declared it. We said that it exists, but we never actually um have the actual we don't have the actual file, the header for it. So remember, you have to include everything that you use. So in here, you have to include now where's the Spring Arm component? Remember that Spring Arm component is under game framework. So game framework slash Spring Arm component. Now what if you didn't want to use this? You would literally go UE Spring Arm component. You would go to documentation and you'll see here the include here, include game framework Spring component. So you just copy this, you'll paste it here. So those are two ways that you have. Either you search it here on your Solution Explorer, or in case you couldn't find it talaga, you can just search it in Google or in camera component. You see here it's under camera component. Same thing here, you can also just camera component and you'll know that it is under camera. So let's also include that. Include camera slash camera component. Okay. So now that we put a definition for the spring arm, for the use spring arm component, all of this will now appear. So I wanted to attach to something. Where do I want to attach it to? For now, I want to attach it to the collider. Remember that when you create a character, it will automatically create a capsule collider, a skeletal mesh. What else does it have? It has something. I forgot. What else does a skeletal mesh collider? I'm pretty sure there's something else. I forgot. So anyway, for now I wanted to in the root component. So remember the root component is whatever root that we set here. In here we said set root component to root. So if you like type in here or if you try to get the root component in here, this is literally this. So automatic lang yan. But for now, I want it stuck to the root component. You could give it some values if you want. Let's say the target offset, target offset is equal to, you see it needs an f vector. F vector, how offset do you want? X, Y, Z for this. Oh, I want to be up. I think I want 200. Okay. Then the camera. You want our camera to be attached. So maybe if you wanted to go further, spring arm length, target arm length. It needs a float 500. I'm not sure with these values. You can always change it in the blueprint. Then the camera is equal to create default sub object, u camera component, camera. Then we want to attach the camera to the spring arm. So camera setup attachment spring arm. Okay, let's compile that. So to create it again, create blueprint, we search it here, demo character, and then BP demo character. An arrow. It has an arrow, right? Tell you where's the forward. Also, I messed up. That's not Y. It's the Z I want to change. Anyway, uh, you can always just change it here. You can change it here. The thing is, if you try to change it here, uh, like 200, right? We changed it here. We compile. It's not gonna change. Even though you close this, open it, it's not gonna change because you're. Never mind, it changed. So that's one way. If you want to change, there's one way. The other is maybe if you want to reload, or if you want just class settings. But it's just blueprint. You can always just change it yourself. You can change the values in here. It works the same way. It's just like the default value now. Okay, so you can just change it here and whatnot. Uh-huh. Then let's give it a let's give it some skeletal mesh. Just use Manny. Let's rotate it 90. Then hold on. Let me just create a game mode. Demo game mode. Always remember to save all the time. In case something's gonna explode, make sure you save all. Okay. When I mean explode, I mean like it's gonna sometimes it'll crash and then whatever changes you did will be gone. So always try to save. Demo game mode. Default pawn is our BP demo character. That's also a reason why I put BP. You cannot different if I just name it demo character, there will be two demo characters. That's why I put BP. It's up to you. If you don't want to put BP, sure, you can rename it. Okay. If I play this, there we go. That's our camera, all the way back here. Okay. Question so far. Is everything clear? All clear? Everyone still following? Everyone asleep. Okay. Yeah. 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 This part, it's kind of boring, but you always have to do this. Each time you create an actor, each time you create a character, in order to give its components, you have to manually type it. So let's talk about the player controller and what Unreal Engine 5 changed. If you followed tutorials of Sir David, I guess, under the project setting, is it under project settings? Yeah, under project settings, and then going to the input. Supposedly it's here. The action mappings, the axis mappings, but you'll notice right now nothing is here in here. And you see here, axis and action mappings are now deprecated. Please use enhanced input actions in input mapping context. So what is this? In Unreal Engine 5, they created this monstrosity called where are you at? Input, input action, and input mapping context. So what is this? Input mapping context is just okay, the action muna. Input action is what kind of value you want to get out with this. Either a vector, a float, a 2D vector, a boolean. It's up to you, right? So we're just looking here the value you want to produce with this. Input mapping context, however, this is where you set what key or what keyboard press or what mouse button press is connected to the input action. So let's say here I want this for this movement input action. For the movement input action, I want it to be 2D, forward, backward, and left and right. So that's 2D. So that's value type. All of this here, you don't really touch it. Triggers, modifiers, I don't really touch it unless you want to learn more about it. Then go ahead. But it has all of these. Right? It's up to you. Uh, that's the action. If you want a key press, I guess it's a boolean. But for now, movement input action, or this is what they usually put. Movement. I think it's IA movement. Yeah. So that's the input action movement. Then let's go to our input mapping context. Uh, Demo input mapping context. Control Shift S, always save. So this is where you have to map things out. So mapping for our for our, we have to choose which one first. IA movement. For our W, I press this, I press W, W. For W, I think should be like this. For S, no, here. For S, backwards, I want it to be the value to go backward, which is modifier negate. You see here, negate is inverts input per axis. Is this right? I think it's wrong. I think it starts with right. I think it's a D what D and A. D is going to the right. That is um forward. A is to the left, that is negative. So negate. I may be wrong here. I might have to switch things up. So anyway, for W, how do we do W? The forward. But since we're only working with negate, which is negative, and just blank, which is just positive, in order to have another axis, you need a modifier called swizzle input axis value. So you see here, useful to map a 1D input onto the y-axis of a 2D action. So if we swizzle it, we are now working on another axis, the y-axis. Yeah, that's probably right. So in this case, for W, which is positive, it's just the swizzle. For oops, wrong. For the backwards, it is the swizzle and the negate. Okay, so let's test it out. Um, to test it out, we need a blueprint, a player controller, uh, demo player controller. Now that doesn't end there. Our suffering does not end there. We need to have uh, mapping context. Hold on, I'm trying to remember. Mapping enhanced. Here, get enhanced input local player subsystem. Uh, this is the one where this is the new enhanced input. So we need to call this, and then we need to mapping context, add mapping context. Then we tell which mapping context. I put the demo input mapping context. Right. So if we use that controller here, demo player controller, we did not forget I forgot to we did not specify a forward backward. Uh ano nga pala to? How do we do this again? Hold on. I'm trying to recall how to map the function to the right. If I right click here, IA movement. So there's this enhanced action event, IA movement. If we had this and we did not do this, this will not work. Because it's weird like that. So on triggered, I just want to add movement. Oh, uh, get character. No, not get your character. Get pawn, get controlled pawn. Sorry, it's been a while. And then add movement input. And then I want to split this. I want to split this. Forward is, I think this way. Ah, sure, that'll work. Is it triggered? Yes. Okay. If I play this, I really did mess it up. X. Where's X again? X. X is forward. X is forward. Yeah. Yeah. I'm just gonna change this here. Here. And then Right. Y is to the right. So anyway, forward, backward, left, right. So that's the uh, input mapping context. If I remove this here, this line, so it's not connected, press play, nothing's happening when I press the keys. If I connect this, it should now work. Okay, so that is the changes for Unreal 5 on the input mapping context. And imagine this: whatever I did in this part right here, you're gonna have to do that in C++. This is where like we are in here kasi I tell you how what actions is should you do when this is called, etc etc. So you have to also do this in C++. Now, fortunately, I do not want you to suffer, so you can always just copy paste some code because even I myself do not remember the the code for it. By the way, let's do that in C++. Uh, player controller, demo controller. Okay. Demo controller, you see here, it's completely blank. It doesn't have anything at all. And we're gonna have to do some stuff here. One, we need the begin. Oh, yep. Just give it some time. We need the begin play. I think that's in protected. It's protected, right? Begin play. Yeah. Virtual void begin play override. Another thing that we need is virtual void set up input component override. So this here, how would you know this? You wouldn't really. It's something that you find out yourself. Also here, well, I mean, it appears here naman. Demo project character. You'll see here in the demo project, the one that's it's created. They have the setup player input component, but it has this. So imagine this code is the actual in the player controller, but they put it on the character itself. So we're actually going to copy parts of this. Okay. So begin play, setup input. I think that's it. No, that's not it. We need the other stuff. I'll just put this here. Pro protected. So what are these other stuff? Remember, we need the input mapping context and the input action. I do not remember it, so we're gonna go here. We need input action value. We need oh, that's it. So oh wait, for here, this part. We need this. So I'm gonna copy that. I'm gonna paste it here. I'm also gonna copy this one, the input mapping context, and let's just get this one also. For here, oh, input mapping context. What did I not copy here? input mapping context. My bad, my bad. So we even here, they're forward declaring it. They're forward declaring it, they're not including it here because circular dependency will not make your code compile. This one I don't need. I can just say edit anywhere. In fact, I think, ano sige, edit anywhere lang. Let's use this move action. Okay. Oh, we need the actual function for moving. That would be void move. And then, well, if you see here, it also has those functions, the look and the move. If input action value, I'm going to copy this. Okay. I don't want you guys to suffer. You don't have to memorize this. Just copy things from the demo itself. Okay. So let us do this. Create a definition. Create a definition. Oops, 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 oops. Not here. Uh-huh. This is just what's happening again in Basprog. It's great. It wants to create the demo project character. Uh, One way to fix that, close open. It's gonna fix things. Or I'll just code it myself here. Void uh demo controller. Oh, yep. I'm already messing up. A demo controller begin play. Do I need to override here? Override. Nah, but I do need this. Base. Oh, no. Super. Begin play. So this is what it calls the base function. That one, I need setup input component. Void a demo controller. Setup input component. In here, I would say a player controller. Setup input component. Because I believe super setup. Oh, it works also. Anyway, that one. And finally, void move. Oh, void a demo controller. Move. Uh, this one. Okay. So um, whatever things that we copied here, the input mapping context, input action, and input action value, we're gonna get the same thing from our demo. Demo. Oops, wrong one. This one. It is this tree. Okay. So this tree, the enhance input component, enhance input subsystem, input action value. We're gonna copy that one. Then remember what we did in the start, in the begin play, right here. Add mapping context. It's also here. Ah, here. Right. Well, we can do it in their input component. Uh, so you see here, it's trying to get the player controller by casting it, get controller. Since we are already working on the player controller, we don't need this part. We can go directly here. So we copy that one. Ta-da! Copy paste. It worked. Default mapping context. So I'm just gonna explain the same thing. It is literally getting the there's an error. We're getting the enhanced input local player subsystem. We are getting it, and from it, we are gonna add mapping context. It is literally this part. But in here, there's an error because player controller is this. Okay, so that's the default mapping context. Now we need to bind the input action, this input action to a function. Do I remember it? No. So I'm just going to copy this part and then I'll explain. Uh-huh. So we're trying to get the enhanced input component. And here we're trying to cast something. This is input component. Then what we want to bind, the action is the move. Oh, sorry. The input action, sorry. The input action here is the move action. Move action. The trigger, remember the trigger here? These triggers, triggered, start, ongoing, cancelled component, completed is the same thing. Remember, E is enum. So you have cancel, completed, ongoing, started, triggered. Then finally here, the ampersand. Remember, ampersand in Basprog is it is getting the address. No, in this case, we're getting the address of move in a demo controller. Okay. Then the move we're gonna have to get to make the controller the player move. So get controlled. So get pawn. So get pawn is the get controlled pawn. Get pawn, arrow, add input, add movement input. But what's a value though? This one kasi is a struct. But we need to get what they did here is they had to change it first. And we're going to do the same thing. Uh, f vector, f vector 2D in input is equal to value dot get f vector 2D. There we go. Then we're gonna put the movement input f vector x is forward, so that's input dot x input dot y 0. Okay, we didn't use begin play. Maybe we could have used it here, but it works the same way. Important. Important, very important. Without this, it will not. This will not work because we're trying to. If you check the, oh, actually, we can check it ourselves. In the actual code here, you see that input component is set there, new object, then register. So without this input component here would be null and it's gonna error. Will it explode? I think it will explode. Okay, so if we compile that, sorry, so that part is actually gonna be very heavy. Medyo like what the heck? But you have to go through it. So if we do the blueprint class of our demo controller, let's call it BP demo player controller. Control Shift S, save everything before shit hits the fan. Then we have this. You have to set this up. The default mapping context will be demo input mapping context. The move action will be IA movement. Compile, Control Shift S. Then I'll just change the controller here. And then finally, you get the same thing. It still works the same way, but all the code is in C++. Questions, clarification, none. Yeah, medyo overtime na tayo dito. But kinda understand. Mabigat yung ano, part na 'to. But, again, for the controller, you don't have to start from scratch. I'd rather not start from scratch because it has so many things that Unreal had to complicate. Before kaya pa yan, memorize 'to. Pero ngayon, all of this, might as well just copy paste it the from the uh, demo, no? So in here, what I did here is we converted it first into the F vector 2D, and then we use that here. How did we know it should be F vector 2D? If you go back here in our move move input action, we said axis 2D, so it should be vector 2D. That's why the X and Y we were able to make it work. Okay. Uh, a few keynotes again. This one, remember, you could search it up where what the component is. Like if you want to use the sphere component, which is the sphere collider, sphere component, it will be here under components. Or if you want spring arm, yeah, static mesh. You want pawn movement. We have the floating pawn movement right here. Okay. Uh-huh. Then remember the U properties. Make sure you're setting the right U property for it. Like if you want it to be visible or edit, if you want it to read write or read only, ayun. So you just have to set it right. Okay, questions, clarification? Um, sabog lahat? None? Okay. So if there are no questions, oh, Sige, while you're doing that, let's go to our big sky. BTIE1. Remember the due date is not really that important. Um, it's just ano, it's just there. Ang pinaka-important is this one. After this, all of this, uh, you cannot submit anymore. So for our run character, it literally is the normal run character. However, we have some C++. Like run character should be a C++ class. You have the string arm, camera. We just did it a while ago. Uh, we create the BP run character. So you have to set the assets like the mesh animation. If you do that in the blueprint, handle callbacks from C++. So this one up to you. You may had you may have some blueprint implementable event or whatnot. Sure, you can do that. Then in here, run character must start as a C++ class. The controller, this you literally just copy what I did a while ago. The forward movement, well, you do that to yourself because I remember our character should be moving forward all the time. And then this one we just did it a while ago. So eh. Here, create your own game mode. We won't have anything here though. We're gonna use it later on milestone 2. Then of course you do the blueprint, and then just for testing, create a large platform. It is literally the same milestone 1 back in GAMPRG 1, but um, C++. Both the run character and the run controller. I mean, you also create the run game mode, but you won't be working on it until the next milestone. Okay. Questions? Clarification about anything? Need po namin to make it move forward. Yes, it says right here. Implement forward movement using tick. This must be overridden manually. So yes, you will code it yourself. How do you code it? You can code it just like what I did. Uh, yeah. Wait lang, I'm trying to remember lang. Ah, if you want pala, eh, in case you want a different direction, no? Because right now you see here, where is this? Right now we set it to the actual just x and y, but if the character is facing to the right, it's still gonna be the x and y will still be based on the world. So if you want, uh, we have uh, what is this? Get actor forward vector f vector forward times input dot x. Does that work? Is inaccessible. Ah, sorry. Get pawn, get forward, get actor forward vector. And then we can do just this one. And then if you want the further right, right, get pawn, get actor right vector times input dot y. Get pawn, add movement input right. So what's happening here is we are multiplying X input to the forward vector and the Y input to the right vector. This one will always tell which way is forward, which way the character or the game of sorry, not game object, the actor is facing. This one will always show to the right side of where the actor is facing. So in this case, if our character here is forward, so it should move forward, this should move right. If we rotate it, you, our forward should be here and not here anymore. So it will go forward, go right. And to test it out, so this is working right. If I rotate our character, that I haven't compiled it, sorry. So yeah, you'll see here our X is still is on the world X. If I compile it and play it there. And then if I rotate this to the right, it will still follow the forward and right vectors. Okay. Anyway, yeah. I mean, if you want to do that, you can do that. So, any more questions? None. None. Sige. Sir, pwede ba mag-request ng 5 sa lab? Last time we checked po. Oh. Can you say after class post should ask helping for? Okay. Yeah, sure. Okay. I will have to request 5.4. Um, for now, you can use 5.2. I'll still accept it. If you want, kung gusto mo, mag 5.2 kayo muna until midterms. Then we'll see if they'll finally install 5.4. Okay. Then yeah, you can stay after this for the fork. So are there any more questions or clarification? None? Okay. So yeah, I want to say sorry na sobrang tagal nito. I mean, it's a long lecture, but kind of important rin. I couldn't skip out on the player controller because you need that for milestone one and also the other stuff. But yeah, ano ko, medyo struggle with the online. But anyway, yeah, that's it for today. You guys can go and enjoy your night. I'll see you guys next time.